To many modern families, summer is the happiest time of the year. To children, it signifies the end of school and 3 long, carefree months of play. To parents and children alike, it's often the time for the yearly vacation to the mountains, the beach, the countryside, or for visits to distant cities, relatives, and friends. Summer in America means active, fun-filled days and warm, dreamy nights. Time to relax, travel, socialize, and enjoy the good life. But it wasn't always this way. There was a time not so long ago when summer was a time of fear and dread. In the first half of the 1900s, people in the United States, and other countries too, panicked when summer came because it brought with it the spread of a terrible and often fatal virus that doctors were powerless to stop. The virus was polio. Polio epidemics held the American people hostage for many decades. Although the disease sometimes struck adults, its victims were almost always children, and so parents and other relatives would spend entire summers anxious and afraid, sometimes moving from place to place to avoid the epidemics. These epidemics almost always hit in summer because that's when children are the most socially active. The virus is contagious. It's transmitted through saliva or fecal matter, usually when infected people fail to wash their hands thoroughly and pass it on by touching someone else or handling someone else's food. During summers, many parents kept their children away from swimming pools and drinking fountains and other areas where the virus could spread. Some left the crowded cities where epidemics were most common and spent their summers in the country. During one terrible epidemic in New York in 1916, some families fled the city only to find they were refused lodging, sometimes at gunpoint, by terrified hotel owners. Officials in New York distributed 500,000 leaflets warning parents to keep their children home from parties, picnics, and outings, and to avoid houses where the Department of Health had posted signs announcing the presence of polio. Children without health certificates were not allowed on trains. Movie theaters often wouldn't allow children in, and even the New York Public Library closed its doors to children at one point. The start of school was delayed 1 month until the epidemic began to decline. In spite of all precautions, there were over 9,000 cases of polio in New York that summer, and over 2,000 of those people died. There were almost 20,000 other cases in 20 different states, and over 7,000 deaths. Polio was not a new disease. Scientists knew it had been around since ancient times because they had found mummies with crippled legs and ancient drawings that showed children with withered arms and legs. But it was always impossible to know when or where it might strike. What wasn't impossible was to know what the results would be. The evidence was everywhere. Thousands of American children who couldn't walk or use their arms, or who were imprisoned in big round machines called iron lungs because they could no longer breathe on their own. People did everything they could to protect their children, but even the strictest precautions often proved futile. The damage that the polio virus caused to its victims depended on how it traveled through the body. The beginning of the disease was always the same. The victim would swallow or breathe in the virus through food, water, or droplets. The virus moved first to the intestinal tract, causing flu-like symptoms, digestive problems, sore throat, headaches, aches and pains, and a high temperature. If the victim was lucky, that would be the end of the disease. The symptoms would recede, the victim would completely recover, and would now be immune to polio forever after. In most cases, this is exactly what happened. In other cases, the virus moved along a far more destructive path. In what was called paralytic polio, the virus moved into the bloodstream and from there into the spinal cord, where it demolished motor nerve cells, the cells that direct the muscles to move. When that happened, the victim ended up with paralyzed arms or legs in any possible combination. Sometimes they were completely paralyzed. One nurse told a story of how she could never forget the teenage boy who lay in bed paralyzed and crying because he couldn't kill himself. In the worst cases, the polio virus traveled to the brain and into the medulla oblongata, what is called the bulb of the brain. In that bulb is the respiratory center of the body. This type of polio, called bulbar polio, was the most feared. Muscles that control the lungs and enable people to breathe were affected, and the victim had to be placed in an iron lung that breathed for them. There are many sad pictures of children confined to these machines, sometimes entire wards of them. Nothing can be seen of the children but their heads and the lonely, tragic expression in their eyes. Their little bodies are hidden within the thick metal tube that encases them. For many years, nobody knew that this was how polio traveled or worked. Some people blamed it on pollution, some thought it came from dirt, and still others thought it was transmitted by animals. Mosquitoes, fleas, flies, and even chickens and fish were blamed. By the time polio was running rampant through America, scientists already knew about vaccinations and their ability to prevent disease. Edward Jenner had discovered the smallpox vaccine, and Louis Pasteur had developed a rabies vaccine. It was now the desperate hope of everyone that someone would soon invent a polio vaccine. In 1935, after years of research, scientists decided to give polio vaccinations a try. The results were disastrous. 2 separate vaccinations were tried, one with killed virus, one with live virus. Not only did neither prevent the disease, but the vaccinations themselves resulted in several deaths. The public plunged back into despair and fear. And then came Jonas Salk. By the time Dr. Salk came along, scientists had already learned to grow the polio virus in large quantities, an essential step in developing a vaccine. They had also identified the 3 different types of polio virus. An effective vaccine would have to immunize against each one. Finally, they knew that the virus travels in the blood before it hits the nervous system, so they could conclude that a vaccine could prevent paralysis by creating antibodies that would attack the virus before it did its worst damage. In the early 1950s, Jonas Salk took up the challenge of the polio vaccine and committed himself to freeing America's children from their crutches, leg braces, and from the hideous iron lung. Salk was born in New York City on October 28, 1914, just 2 years before the huge polio epidemic that drove so many New Yorkers into the country. His parents were Jewish immigrants from Russia who both worked in the garment industry. He was a bright child who, one teacher said, read everything he could get his hands on. When he was 12, he was accepted to a free experimental school for gifted students, where he thrived on the competition and went to the top of the class. He enrolled in college when he was just 15 years old, with plans to become a lawyer. He had another dream, too. He was determined that someday he would do his own work in his own way. Salk, even as a youth, hated the idea of working under others. In high school, Salk had taken only one science course. His greatest love had been literature, and all his life he enjoyed quoting Ralph Waldo Emerson, Henry David Thoreau, and Abraham Lincoln. He also liked classical music and dancing, but he never took an interest in sports. He was too small. Salk worked his way through college with part-time jobs and scholarships. He decided to take a few science courses, simply because he'd never tried them. He was amazed to see how much he enjoyed them, and soon he changed his goal from law school to medical school. Like most of the goals he set, he reached it. Although his parents hoped he would start a private practice in New York, Salk was far less interested in practicing medicine than he was in research. When he applied to medical school and was warned he'd never get rich in research, Salk responded, "There is more in life than money." He attended medical school at New York University, where he spent a few months under the tutelage of the famous microbiologist Thomas Francis. Francis was known for his discovery of one particular flu virus and for his work in trying to find a vaccine against the flu. He was one of the very few scientists interested in killed virus vaccines, vaccines that use a dead virus to stimulate the body's immune system. During his senior year at medical school, Salk met a young Smith graduate who was working in social welfare named Donna Lindsay. Both loved to dance, and both were dedicated to lives of service. They were married the day after Salk graduated in 1939. Then Salk began his internship at Mount Sinai Hospital. Salk was an excellent intern and an excellent doctor. He was especially skilled at diagnosis and at surgery, but he could never get his mind off Dr. Francis' lab and the work being done on viruses and immunities. When he finished his internship, he returned to Dr. Francis, who was now directing a laboratory at the University of Michigan. It was 1942 when Salk began his work at Michigan, and the United States was at war. Everyone remembered the terrible toll that flu epidemics had taken on soldiers in World War I. 22 million people had died, twice as many as had died in the fighting. 500,000 of those people had been Americans, many of them soldiers. No one wanted the tragedy to repeat itself in World War II. Dr. Francis and his laboratory had been given a large grant from the U.S. government to help find a flu vaccine. At the same time, he'd been given a grant from the National Foundation for Infantile Paralysis, another term for polio, to study epidemics of that disease. That foundation owed its success to two different men, one of whom knew a great deal about polio firsthand, President Franklin Delano Roosevelt. In 1921, when Roosevelt was a vigorous young politician, 39 years old and in the prime of his life, he one day took a swim in the waters off his home in Campobello, Maine. After the swim, he came down with a fever and pains throughout his body. Shortly after that, his arms, his hands, his legs, and his back became paralyzed. After a few weeks of confusion, the doctors were able to make a diagnosis: polio. Roosevelt had just returned from trips to the hot and crowded cities of Washington, D.C. and New York City. It's not known where he caught polio. What is known is that with the help and support of his wife Eleanor, he decided to fight back. With exercise, swimming, and determination, he was able to regain the use of his hands and arms, but his legs remained crippled. At first, the illness was kept secret. Photographs only showed him from the waist up, looking as vigorous as always. He usually used a wheelchair, but now and then, like at the Democratic National Convention, he would use leg braces and crutches. Roosevelt spent his life looking for cures to his paralysis: spas, hot packs, and massages, among other things. In 1938, Roosevelt and a law partner named Basil O'Connor set up the National Foundation for Infantile Paralysis to raise funds to help victims of the disease and to support the research that eventually spelled the end of polio. He raised enormous funds for the foundation, much of it through his March of Dimes campaign. Those funds would later make it possible for Jonas Salk to accomplish his greatest work. But first, with Dr. Francis, he set out to tackle the flu. While Salk worked at the lab in Michigan, he and Donna lived in a rented farmhouse outside the university town of Ann Arbor. They grew vegetables, canned their own food, and took walks in the country. They had 2 sons in Ann Arbor, and a few years later, they had a third. Meanwhile, at the laboratory, things were going equally well. Francis and Salk were able to develop a successful flu vaccine that was used on millions of American soldiers in the 1940s. In addition to possibly preventing another epidemic, it proved their theory that a killed virus vaccine could be effective. 5 years passed in Ann Arbor, and Salk, now in his 30s, felt an increasing desire to fulfill his dream of working independently. Although he and Francis worked well together, and Francis was always careful to give him credit for his contributions, Salk wanted a laboratory of his own. He found one in Pittsburgh, Pennsylvania. He was 33 when he joined the University of Pittsburgh School of Medicine, a school so happy to have the famous flu researcher that they promised to help him set up his own laboratory. Then, one day, the school had a visitor who would change the course of Salk's research and of his entire career. The visitor was from the National Foundation of Infantile Paralysis, the foundation set up by Roosevelt that had earlier given a grant to Francis' lab. Now he approached Salk with a question. Exactly how many types of polio were there? Scientists thought they knew there were 3 basic types, but the various strains hadn't been identified, and there might be hundreds of them. Would Salk be interested in investigating the problem? Salk certainly was interested. He immediately set to work designing his laboratory, hiring a staff, and gathering the materials he would need. It was clear to everyone what was on his mind. He would identify the strains as requested, but he would also be thinking about a vaccine. Salk worked hard on identifying the polio strains. He was, according to his wife, a perfectionist who was happiest when he did everything himself. He avoided reporters and articles about his work because he felt they were usually inaccurate. He also never allowed any stories about his personal life, which he tried desperately to keep separate and private. After long hours of intensive labor, he completed his work and identified over 100 polio viruses and to which of the 3 basic types each belonged. When one reporter wrote an article that he actually found to be accurate and fair, Salk became inspired with the idea of how publicity could help his cause. He began cooperating with journalists and even gave public speeches about polio work, at which he was said to be very eloquent and convincing. This raised the eyebrows of some of his old-fashioned colleagues, who accused him of glory-seeking. Salk began to lobby the Foundation of Infantile Paralysis for more materials and funds, this time to pursue his idea of developing a vaccine. After initial hesitation, after all, he'd been hired to type the viruses, not to find a cure, the foundation agreed and gave him a large grant. The director of the foundation later said of Salk, "Jonas is in touch with the world. I don't mean that he's worldly. He's not. But he's a human scientist, or call him humane or humanitarian or humanistic. He is aware of the world and concerned about it. He sees beyond the microscope." In 1951, at the age of 37, Jonas Salk set to work full-time to find a solution to one of the greatest medical problems that had ever faced America. For 2 years, Salk grew polio cultures, experimented with ways to kill the virus to make a dead virus vaccine, tried his vaccines out on monkeys, and pored over his results. He worked day and night, and in the few hours that he wasn't working, he was completely distracted. Mrs. Salk liked to tell the story of how one night when she complained he wasn't listening to her, Salk absent-mindedly responded, "My dear, you have my undevoted attention." By 1953, he had come up with a vaccine he thought might just work. Salk had taken the 3 strains of poliovirus and killed them in a formalin solution. Formalin is made from formaldehyde. Then he'd found that even though the virus was dead, as he'd always believed would happen, the body still made antibodies against it. He had tested the virus first on animals, but now he knew he must test it on humans. The obvious first choice for his tests were children who already had polio. They would be safer because they already had antibodies. He did some secret trial vaccinations at one school and one home for crippled children. The parents of these children, who had suffered terribly from their tragedies, were anxious to be of help and to perhaps facilitate a cure. Salk wanted to see if this vaccine would increase the number of antibodies already present in the children's systems. He gave them their injections and returned the next day to take blood samples and to see how they were doing. At the time, he said, "When you inoculate children with a polio vaccine, you don't sleep well for 2 or 3 months." His next experiment was even riskier. He vaccinated children who had no polio antibodies in their blood and waited to see if the vaccine would produce any. The results were outstanding. The children who already had antibodies produced even more, and the children who had none to start with now had antibodies in their blood. Salk called this experience the thrill of my life. But even though the vaccinations increased the antibodies against the disease considerably, he still didn't know if his methods were absolutely safe. He announced his plans for a large testing of the virus on about 25,000 children in spring of 1954. And for the first time, he revealed the experimental inoculations he'd already given children and the promising results. It was right about then that Salk's research triggered one of the most heated and bitter controversies in the history of medicine. On one side of the issue were the scientists like Salk who believed a polio vaccine should be made of killed viruses. On the other side of the argument were scientists who insisted an effective vaccine had to be made from live viruses. That side was led by a professor of pediatrics from Cincinnati named Albert Sabin. Sabin's approach was to use live viruses that had first been modified, attenuated is the scientific term, by repeated passage through animals. With each passage, the virus became less deadly, but still strong enough to cause antibodies to develop. To Sabin, a long-term life immunity could only result from live vaccine. A killed virus like Salk's, he believed, would provide only temporary immunity. Sabin had been developing such a live virus vaccine and believed it would be ready for trial within a few years. Meanwhile, it became his personal cause to block the trial of the Salk vaccine. Salk and Sabin launched a professional and personal war against each other that caught the attention of the scientific community, the press, and the public. Sabin, who was an older man, saw Salk as a publicity-seeking upstart. Salk, on the other hand, found Sabin pompous and condescending. It's true that Salk worked hard to publicize his discovery, but he never received money from the sale of it. When someone asked him who owned the patent, he replied, "The people. Could you patent the sun?" At one point, when the press misled the public into thinking a vaccine had been developed, proved, and would be in use before the next summer, Salk himself went on the radio to explain to the American people that this wasn't the case. He described in clear, non-scientific terms what had been accomplished and what work remained. He stressed the importance of caution, safety, and confidence, but he also gave the public hope. He guaranteed them that the discovery of an effective vaccine was just a matter of time. Never before had the radio audience been addressed directly by a scientist. Salk became famous overnight, and Sabin doubled his efforts to stop him. Rivalry and feuds in the field of science are almost as old as the field itself. For centuries, scientists have involved themselves in fiery debates that often become personal. They competed to make discoveries, to get credit for their discoveries, and to discredit their opponents. There were accusations of sabotage, lying, plagiarism, and deceit that go back to the very beginnings of the profession. Almost always, these competitions, as ugly as they could be, led to new research and discoveries, like the irritation that creates a pearl in the oyster. In the case of the battle of the two scientific giants, Salk and Sabin, there was indeed a pearl, one that saved the lives of thousands. Salk worked harder than ever to perfect his upcoming tests on the vaccine. He took naps instead of going to bed at night, and he ate sandwiches while working at his desk. To prepare for his testing in the general public, Salk first tested his vaccine on himself, then on a few trusting friends and family members. He gave his sons their inoculations while they slept so they wouldn't be frightened. His 3-year-old son, Jonathan, became the youngest person to ever receive a polio vaccination. Asked years later about experimenting on himself, Salk said, "I look at it as ritual and symbolic. You wouldn't do unto others that which you wouldn't do unto yourself." After weeks of bitter debate, the Vaccine Advisory Committee finally voted to proceed with the trial of the Salk vaccine. The date for the first test was set for February 1954, and the place was Pittsburgh, Pennsylvania. The children receiving it would all be second graders, the group most vulnerable to polio. 5,000 children were inoculated that day, 137 by Dr. Salk himself, who averaged 1 child a minute. There were no problems with the vaccine, although it would be months before its effectiveness could be judged. Encouraged by the results, the government then gave Salk permission for a broad public field test to be held on April 26, 1954. The first public polio vaccinations were an astounding event. American parents were so anxious to protect their children from this terrible disease that over 650,000 children showed up to be inoculated in 44 different states. All were vaccinated, and some were given placebos, a harmless neutral substance that contained no vaccine, so that scientists could make accurate comparisons. It took an army of thousands of volunteers to help administer the vaccine. There were 20,000 doctors, 40,000 nurses, 14,000 school principals, and 200,000 citizens who offered volunteer help. They set up centers for the vaccinations, drove people around, picked up permission slips from parents, and worked with journalists. It seemed as if all America had rallied to work together to end the horrible threat of polio. Then the world sat back and waited for the results. The task of monitoring the results went to Dr. Tom Francis, Salk's old mentor and colleague from Ann Arbor, Michigan. It was an enormous task. In private, he was to review the meticulous results on the injections and evaluate their effectiveness. He was also told to compare the records of children who had not received shots with those who had. Francis was to address himself to 3 critical questions. How many vaccinated children got polio? How many children who were given placebos came down with polio? How many of the children who had no shots at all came down with polio? The evaluation would take 1 year. On April 12, 1955, the 10th anniversary of the death of President Franklin Roosevelt, Dr. Francis was ready to give his report. 500 invited guests waited anxiously for him to begin. Outside, reporters from all over America clamored to get inside and to hear what the results were. When the results were released, they made banner headlines all across the country. Dr. Francis had concluded the vaccine was safe and effective. It was 60 to 70% effective against type 1 paralysis and over 90% effective against types 2 and 3. It was 94% effective against the horrible bulbar form that sentenced victims to the iron lung. Overall, said Francis, Salk's vaccine was 80 to 90% effective against polio. Salk was pleased. but he maintained the vaccine would have been 100% effective had it not been mixed with merthiolate, a germ killer that the National Institute of Health insisted on against his wishes. Instantly, Salk was a national hero. People everywhere now referred to his vaccine as the Salk vaccine, but he himself never called it anything but the poliomyelitis vaccine. The atmosphere across America was celebratory that day. It seemed as if science had finally triumphed in its war against polio. People honked their horns and churches rang their bells. School principals called special assemblies to announce to the students that polio had been conquered. People went to temples and churches to thank God. Salk and his family were deluged with flowers, cards, candy, and gifts, all of which he returned. Hollywood studios called to see if they could get the rights to his life story, which he refused to sell. Babies born that day were named after him, and so were schools and hospitals. The Salk family went to the White House and met the president, where Salk spent all his time talking about the other scientists and researchers who had worked so hard and deserved recognition. Through it all, Salk struggled for his privacy and became more and more sensitive to how negatively other scientists were reacting to the attention he received. He tried to stop the hoopla, but he had little effect. The American public was ecstatic. And then, only 2 weeks later, the triumph turned to despair. The first report came on April 25, 1955. A baby inoculated in Chicago had developed paralytic polio from the vaccine. The next day came the report that 5 children in California were paralyzed from the vaccinations. Over the following days, more and more reports came in until it became apparent that over 200 children had contracted polio from their injections. 3/4 of them were paralyzed, and 11 children died. But all the children had been injected with a vaccine made from the same laboratory, the Cutter Laboratories. 6 companies had produced the vaccine, and not one of them had followed Salk's strict requirements, but only the Cutter vaccine resulted in tragedy. At once, a halt was called to the vaccinations while the Surgeon General launched an investigation. Salk's nemesis, Albert Sabin, leapt at the opportunity to proclaim that the Salk program should be abandoned altogether. Throughout the crisis, Salk never once lost faith in his vaccine. He was close to losing everything he'd worked for, but he believed in his heart that the problem had to be in the Cutter Laboratory and that he would be vindicated. Soon he was proved right. It was discovered that the Cutter Labs had left live viruses in over 50% of their vaccine. A committee of experts that included both Salk and Sabin later voted to restart the program with more stringent inspection of the companies producing the vaccine. Sabin voted against that decision. Salk himself refrained from casting any vote. Once parents realized that the error had come out of the Cutter Laboratories and that the new vaccine was safe, they again brought their children to be inoculated. In the years that followed, hundreds of thousands more children were inoculated, and there were no further cases of polio from the Salk vaccine. As a disease, polio rapidly began to fade. In 1952, there were 58,000 cases of polio. 10 years later, in 1962, there were only 900 cases. Even Salk was surprised at the success of his vaccine. He never dreamed polio would decline so quickly. Dr. Sabin released his own vaccine based on live polioviruses in 1957. Since so many children in America had received the Salk vaccine, he did his testing in Russia, the country where he was born. The test was a success, and the Sabin vaccine became licensed for use in the United States in 1961. Now, the Sabin vaccine is used almost exclusively because it's less expensive and easier to administer than Salk's. Salk's was given by injection. Sabin's is given orally, originally in sugar cubes. Today, polio has virtually disappeared in the Western world, and there is hope that it will soon disappear from the entire planet. After he had proven his polio vaccine, Salk founded the Salk Institute for Biological Studies in San Diego, California. There, scholars from all over the world can pursue their studies in private or in collaboration with other researchers. In 1968, he and his wife Donna divorced after 29 years of marriage, and the next year Salk married Françoise Gillot. Gillot, a French woman, was a famous beauty known for her long love affair with the artist Pablo Picasso. She was the mother of Picasso's 2 children, Paloma and Claude. After his second marriage, Salk took an interest in philosophy and wrote several books on the subject. In one, entitled Man Unfolding, he talked about science and said, "Ideas are not unlike food, vitamins, or vaccines because they stimulate growth and development. Because the effects of ideas are unpredictable, they lead to many new experiences." Salk retired from research in 1985, but he later returned to work when a new challenge, even mightier than polio, confronted the medical community: AIDS. He worked on a vaccine against AIDS all through the 80s, and that work continues at his institute. Dr. Salk's life came to a quiet end on June 23, 1995, when he succumbed to congestive heart failure at the age of 80. Jonas Salk was never a very public man. He spent most of his career trying to avoid attention and trying to convince people that the credit for a polio vaccine belonged to many scientists who had worked equally as hard as he had. Still, he was shunned by parts of the scientific community his whole life. He was never invited to join their most prestigious organizations. He never received a Nobel Prize for his work, and for years he suffered the criticism and contempt of many of his colleagues. He was never discouraged or even affected greatly by the competitiveness and jealousies of his profession. He kept his mind on his task, and he kept his faith in his own work. There are millions of middle-aged Americans who can be heartily grateful he did. They are Americans who walk without crutches and braces, whose legs and arms are healthy, whose lungs breathe on their own, and who are free from the fear their own parents suffered, that their children might someday be struck down by the destructive virus of polio. Today, the Salk vaccine is being put back to use in the Third World, where oral vaccines proved ineffective because patients could not easily make the several trips required for multiple doses. The hope is that Salk will soon do for those countries what he did for the West. And when that happens, as it surely must, the entire world will finally be free of polio.